Hi, this is S1 Jamalla, and my thesis title is like skin cancer detection using deep learning and 3D total body photography. And this is advanced data analysis where what I did taking insights from the data set, and actually the data set contains lots of data, and I used like NumPy, Torch, and is like neural networks, and Pandas for the using CSV and folders and all. And you can see here I trained my data set, and this is my training metadata.csv and test metadata.csv. And these are all the columns and rows where I printed. You're gonna see IDX1, IDX2. These are the main features like which gonna decide like malignant or benign. It's gonna you can see here like benign is like a it's not a cancer actually, and there will be like malignant, it's gonna be cancer. You can see the target values and all, and so that we're gonna classify all the code like in the ADA1 it will be only CSV files, like training and testing CSV files, and ADA2 will be like doing analysis regarding the training and testing images, and also the ADA3 it is a final analysis like removing all the unwanted like null values and everything, and printing and plotting the target values like implementing the 0 and milligram dot benign values. And you can see here some of the plottings, and these are all the data which present in there, and these are all the null values. There are so many null values in this, and we're gonna remove all these things. And I'm using random forest classifier for all the analysis and all, and you can see the futures over here. And the main thing of these three files are like they're gonna classifying the algorithms, like storing, searching, and like divide and conquer, like programming, like dynamic programming things and all, like graphical analysis. And you can see all the things in this part, like data analysis part. Like you can see the heat map, like correlated heat map. You can see there are so much of correlated things over here. And this is also one of the plotting technique, like a violent plot. I use this violent plot over here. And let's go wipe up this session. And these are the libraries which I'm using. And I'm importing all the data and putting the speed to implement faster because of the I was having so much of data. I'm using GPU and all, and training metadata, like simply printing some of the data at the starting, and I started training my images here, and training all the images and seeing the height, width, and channels of the images, like printing some of the few images data. And here is all the total number of images, like how many images were there, how many negative images, how many positive images. These are the positive and negative images, and 393 are like malignant images we have. There is so much of positive, like benign images, like negative images we have. Only few positive images we're gonna have in the data set. And these are the some of the columns. And here the main thing of this plotting technique is like scatter plot using is like I said you before, like IDX, like IDX1, IDX2, IDX3. These are the main things we're gonna it gonna decide like benign or malignant. See, you can see that benign is like red mark. It is not a positive thing, and malignant is the positive where we're gonna have the cancer. So that I am taking few criterias and I'm printing all this data. These are the medical terminologies, like they're gonna mention the citations, and these are all the plotting I did. And I gonna show you the images like at the end. And these are the image representation, like you can see all the like positive and negative, how the like what's the height, what's the width, and what's the accuracy. You can see like TDP LEYA is like area of the plot, and it's like each and every part they are going to mention in this data set, so that I am printing out all the weights and all here. And this is the deep learning PyTorch, and this is the community model what I'm using here now. And you can see is there is an one target size of 32, 33, 38, and 4. and this is the target value, and you can see the ones here somewhere, like a few ones. This is the like positive cases what we have. Each training batch has a shape of 32 3, 38 4, and 38 4 means like 32 RGB images, and it is like 384 into 284 resolution images, and the target is like binary 0 and 1. And these are the images how it's gonna look. And let's go here. These are some of the data analysis I did regarding, and you can see all the columns and thing. And these are the representation of the futures, how many futures we have. And you can see all the target values. And these are the plotting. And let's go to the Fastai and over sampling using ResNet 50. What I mentioned in the thing, like if I want to use this ResNet 50, I use this and I did some analysis. I got a good accuracy by using ResNet 50, like not oversampled images. You can see the accuracy of 99%, 99% of accuracy, and these are the target values and results. Like how it is like predicted. The value close to 1.0 means that model is highly configured the images and melanoma. The value is close to 0.0 means the model is configured it is not melanoma, and then value around 0.5 means the model is uncertain, like it's like that. And oversampling of images, you can see the oversampling of images. I created a new data like href file, and which contains the oversampling of images. You can see all the training going here, and these are the images how it's gonna look. I shaped all the images here, so you can see href file which gonna contains all these images like oversampled images. And these are all the like positives. You can see the negative cases and positive cases over here. I'm just representing the rows in the oversampling image. This is the only part like where I did the oversampling, and you can see the total number of images like 11,000 around, like 1,10,000 around, and you can see 1 lakh are like negative thousand, like 10,000 are like positive images we do have, and you can see like positive and images criteria over here. And 10K to 2K model, this is nothing but like training 10K images, like 10,000 images, and training 1K images. And here's the full code regarding those. You can see the accuracy scores and all. But when I'm training a large amount of data, I'm getting a good accuracy. When I'm training the less amount of data, I'm not getting a good accuracy. And but like it's been like more data and good accuracy. You can see this like plotting and all melanoma and one. You can see this percentage, and you can decide that like classifying as the melanoma and 1 and classifying not melanoma as 0. It's like target should be greater than it is like melanoma. If it is like less than, it is like benign. And the PyTorch analysis, like deep learning analysis, you can see the image metadata combination combined, and these are the image and metadata. You can see the images what I wanna take over here in the implementation. You can see the accuracy score as well. They are like some of the malignant images, and I think these are like malignant, not malignant images actually. The less than 0.05, and this is all the code I was using. You can see the accuracy over here, and the deep learning images, and some few data analysis to represent few files and data and all. Starting deep learning PyTorch, this is from the community model. This is the full code I took from there, and this is all the analysis what I'm doing, like using ResNet 50, and checking the accuracy scores and all, like continuous, and you can see the files like continuous and control variables and all. This is all the code, and you can see the device touching like CUDA. This is the CUDA which I'm using for the training, like it's a training GPU what I'm using. And you can see the accuracy like torch is like 0.167. This is the good accuracy. Actually the training is very good regarding this analysis, and I did few more analysis, but I'm like using Google Net and things and all, but I was getting very less accuracy compared to this, and this is the final thing. Thank you.